of some more types we'll see like this. We'll discuss some special types of standard integrals which are based on the techniques of integration by parts. So we can directly write the answer when we solve the questions. If I is under root x square minus a square dx, just take this as I. So you have 1 into under root x square minus a square. Take 1 as the constant function, which is 1, as the second function, and now integrate. You are taking the constant, this one, as the second function. So what you get? X under root x square minus a square. You are taking, you have to integrate 1, that is, you will get x. Then integration of again 1 will this x will come, and differentiation of this one. So you get this. Differentiation of this is this. And when you you have got this. This can be written as, because this is x square. 2 gets cancelled. This can be written as x square can be written as x square minus a square plus a square. We are just adding to solve it. And when we write this, we can take this out and take this out. We can integrate them separately. So integration of this is what? This is I only. We have started with this only, right? And this is a simple integration, dx by under root x square minus a square. See, this I has gone there, 2i is there. Now you have to integrate dx by under root x square minus a square. You have got this. This is I. And this will simply, this integration of this will be nothing but divided by I, divided by 2. But we have to solve this also. How to solve? We know the standard form. So this is nothing but log x plus under root x square plus a square. A square will remain like this. 2 has come from here, and this also has 2 in the denominator. So this is the standard solution. So we can solve these also in this similar fashion, or in the first, second, third. What we have seen, these are the standard forms. You can also use the x is equal to a square theta, x equal to a tan theta here, in this one, x equal to a sin theta here, so that you can solve it. And the way I told you also is good. So let us apply what we have just seen in the problems. This x square plus 2x plus 5 can be written as x square plus 1 plus 4. So still we have to, we want some single variable here. So put x plus 1 equal to y, dx equal to dy. The integration of this will be y square. This will become y square plus 2 square dy. Now, we have a standard solution for this one. And just place y equal to x plus 1, you will get a standard solution. Here also, we have to make it in some form, a square minus x square form. So 4 square minus x plus 1 whole square is similar to this. So now we put x plus 1 equal to y. We put x plus 1 equal to y. So dx will be equal to dy. This can be written as 4 minus y whole square dy. This is 2 square. So this is a form of under root a square minus x square. This is the standard solution. And y can be now placed as x plus 1. So just place x plus 1, you will get the answer. So this is one more part.